David Smith here with one more flipped classroom math lesson. 3 tips before we start. First, remember that you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to jot down some notes or write down some questions for our next class. Lastly, you can turn on the captions so you can read my words go by on the screen. Today's lesson is going to cover a bunch of different laws that help us manipulate and simplify logarithmic expressions. And I personally think these are kind of cool. It's a nice little exercise in manipulating expressions using some of these laws, and you'd be surprised at how a fairly complex looking expression can be simplified right on down. So let's take a look at the first 2. So check this out. Log base A of A is 1. Now if you think about that for a minute, it makes total sense. This is asking what power of A makes A. So of course, that's 1, because A to the 1 is A. This one, log base A of 1 equals 0. And if you think about this one, it also makes sense. This is saying what power of A makes 1. And that's the 0 power. Anything to the 0 power makes 1. The next 2 laws relate to multiplication and division. And that's this one and that one. So if you have log base A of x times y, 2 quantities times each other, then that's going to equal out to log base A of the first quantity plus log base A of the second quantity. Division is very similar. If you have log base A of x divided by y, that's just going to wind up being log base A of x minus log base A of y. And this relates because one way to look at multiplication is its repeated addition. We're just adding again and again and again until we satisfy that prompt. Division is just repeated subtraction. We're just subtracting as many times as we're required to by the prompt. 2 more laws and then we'll do some problems. So check this one out. This is like a power law. If we have log base A of x and we're raising that to a power, if this is x to some power, you can take the power out and put it in front of the log expression. So log base A of x to the p is the same as p times log base A of x. So that's another manipulation you can do. This last one looks bizarre, but it actually boils down. It's pretty straightforward. So check this out. If we have log base A of log base A of x, that's x. Now let's unpack this a little bit. Log base A of x, that's asking us what power of A makes x. So this expression is the power of A that makes x, whatever that power is. So this question is saying, what power of A makes x? So this has to be the power. So this has to equal to x. Okay, let's do some problems. Okay, I've got 3 problems queued up here that use some of those first of those 6 laws that we have. So here's a prompt that you're going to see. Write as one logarithmic expression. Now here we've got, in each case, we've got 2 things in our expression, so we need to simplify that down. So the first one, that's 1 log plus another, same base. So go take a look at your rules, look at what you can do, and come back once you've done that. So using that first, or no, I guess it was the third one that we covered there, using that in reverse, you have the same base. Got to have the same base to be able to do these things. I've got 1 log plus another log. So that rule lets me say that this is just 1 log of this times that, which is what I wrote there. And I did my math. So this simplifies down to log base 8 of 18. Now, an important point to note. In these problems, you do need to simplify as far as you can. So just remember that. Okay, next one. Log base 5 of 9 minus log base 5 of 3. So go ahead, pause the video, use one of those laws, and simplify that on down to 1 expression. All right, so here we go. We know subtraction in 2 logs is division in 1. Same basis, so we can do that. So I get log base 5 of 9 over 3, which gives me log base 5 of 3. Okay, last one. Now this one is a little bit more tricky. Check it out. I've got log base 7 of 6 minus 1. So how can I combine these 2 things? This requires a critical thinking step. Look back at those 6 rules, and And there's one here that's going to let you do this just fine. So if you recall, one of those first rules was log base A of A equals 1. So this is 1. So I just did log base 7 of 7. That's 1. So I rewrote this expression. Now I have two logs of the same base, one subtracted from the other, so I can go ahead and simplify that. This is going to be log base 7 of 6 over 7. There you have it. Okay, let's do a more complex one. This is going to take a few steps to do that. So what I have here is 2 log base 10 of 5, and I'm adding 2 to that. So I want you to just play around with this. There's no set one number of steps to solve it. You can create more steps. You might investigate down a dead end and have to come back a little bit. But all those laws are going to be really helpful, and you can simplify this down to one log, one base, and one number. So go ahead and give that a try. Then I'll come back and give you a hint in case you got stuck. Okay, so the first term was pretty straightforward. It was that power rule with the P on it. I just took my 2 and I raised my number to that 2. So I wrote log base 10 of 5 squared. So that's that first term. Now this one's a little more tricky. How can I state 2 as a logarithm? And more importantly, I do want a base 10 log because I'm trying to combine these two. Now, fortunately, this is on the easier side because this is just log base 10 of 100. This is asking us what power of 10 makes 100. So this expression here is 2. So I just changed the 2 into a log base 10 expression. And now you see how we can probably finish this. So pause the video if you haven't already done so and go ahead and finish that calculation and come right back. All right, here we go. So I just went ahead and I squared by 5. So I have log base 10 of 25 plus log base 10 of 100. When I do that, when I have addition, that's multiplication inside of one log. So I have log base 10 of 25 times 100, or log base 10 of 2500. Okay, let's do an interesting one. Now this one is going to have a couple ways to do it. So we're going to do it one way first, and then we're going to do it a different way. All this involves critical thinking with exponents, powers, and bases, things like that. So here we have a log base 3 of 27 plus 9. So check it out. You know how to do this one. This is just going to be log base 3 of 27 times 9, which is 243. Now, simplification is not done with this one. And I want you to think about that real quick. Like maybe pause the video and look at this number 243, because there's something we can do with that. That's a number that maybe should have your attention. And I'll tell you why. 243 is a power of 3. So with that hint, go ahead and finish that log. 243, I hope you found this, is 3 to the 5th power. So this gives me log base 3 of 3 to the 5. And by one of the first two laws, we know that this is 5. Because remember, this is saying what power of 3 makes 3 to the 5. So that's automatically going to be 5. So check this out. It's kind of cool, right? This is a pretty complicated log expression. Lots going on there. But because we picked numbers that are all related to powers of 3 and we have a base of 3, this thing resolves down to just a number. So be ready for those. Now let's look at the other way to do this. And in some ways, this is actually a little bit more simple. So check this out. Log base 3 of 27. That could be written like this. Log base 3 of 3 to the 3rd, right? 27 is 3 to the 3rd. And then we could do this one as log base 3 of 3 squared, okay? Because that's true. 9 is 3 squared, 27 is 3 to the 3rd. Now, by using that last law we used solving it the other way, we know that this is 3, and we know that that is 2. So we get 5 that way as well. So completely different way of solving it, but it works and it's correct. Okay, here is a prompt that creates what I think you might find is a little bit of a contrived type of a problem, but it is going to test your understanding of logs and a little bit of algebra. So check this out. What they're saying, here's the setup, is that the variable x is log 2. The variable y is log 6. So what they're going to prompt you to do is write this thing in terms of x and y. So I'm going to walk you through that because this is a little bit difficult, I think, at first to tease out. So we're looking to write this. Our answer is going to be x and y in some expression, right? So x is log 2, y is log 6. So I notice with 12, I have 2 times 6 in there. So I can rewrite this as log 2 plus log 6, right? That's how we can break that down. This is log of 2 times 6, so that breaks down to log 2 plus log 6. Now we're pretty much there, right? X is log 2, so this is going to be x plus y, because y is log 6. So that satisfies that prompt. Now, let's do another one. They get a little bit more complicated. Okay, same prompt, same conditions. X is log 2, y is log 6. Now, they're starting you off with log 3. So think about how you might manipulate this a little bit to wind up with x and y. All right, so the key step here was to realize that 3 is 6 divided by 2. And again, I'm shooting for these numbers because that allows me to get to my x and my y. So this is log 6 over 2, which is the same as log 6 minus log 2, which gets us x minus y. Okay, this one's a little bit more complicated, but totally doable. So now we're going to have to do this for log 48. So pay attention to your factors of 48 and see what you come up with. All right, let me give you a little bit of a nudge in case you couldn't get any further. This one, 48 is 6 times 8. 8 is 2 to the 3rd power. So we have the log of 2 to the 3 times the log of 6. So now you should be able to use your laws to simplify this on down to something with just x and y. So give that a shot. Okay, so what I did is, since we've got multiplication right in here between these two terms, I could separate them out with their own logs, separated by plus. So we've got log 2 to the 3rd plus log 6. Now I'm going to take this one, use that power-ish rule, bring the 3 down. So now I have 3 log 2 plus log 6. Now, if log 2 is x and log 6 is y, then really what I end up with is 3x plus y. That's how you do that one. Now that you've watched the video, jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that challenged you the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.